السلام عليكم. اهلا بيكم حبايبي طلاب OL Edexcel IGCSE. احنا النهارده ان شاء الله هناخد first part اللي هو states of matter. هو هينفع مع linear وهينفع كمان مع modular، بس هو موجه للمودولر، بس نفس الكونتنت بالظبط موجودة في اللينير. وهتكلم شوية in details على نظام المودولر، وهقولك كل يونت فيها ايه، وهنشرح مع بعض إن شاء الله بالتفصيل. أنا معاكم دكتور أحمد عيد. خلينا نبدأ مع بعض كده من البداية. مبدئيا الكيميكال كونتنت أو الكيمستري كونتنت هو في الموديلر بيكون divided into two units. اليونت الأولانية بتكون فيها ال principle of chemistry. طبعا خلي بالك إن ال two units فيهم نفس الحاجات، يعني يونت 1 زي يونت 2 فيها نفس المين topics أو ال principle of chemistry موجود هنا وهنا، ال physical inorganic و organic، بس كل unit بيبقى فيها some lessons أو some topics. خلينا نقول إن ال principle of chemistry part 1 ده موجود في unit 1، هيكون فيه states of matter ودي اللي هنتكلم عليها النهاردة. هيكون فيه elements, compounds and mixture, atomic structure, the periodic table, chemical formulae, equations and calculations. وخد بالك إن ال chemical formulae والايكويشنز والكالكيوليشنز والبريودك تيبل موجودين كمان في يونت 2. طيب بالنسبة للجزء الانورجانيك في يونت 1 عندنا reactivity series، عندنا extraction and uses of metals, acids, alkalis and titration، و acids, bases and salt preparations. physical chemistry part 1 هيكون في energetics، والorganic في يونت 1 هتكون سهلة قوي لأن هيكون فيها introduction, crude oil, alkenes والكينز. طيب بالنسبة ليونت 2 طبعا قلنا ال principle of chemistry هيكون فيها ال periodic table تاني والchemical formula والequations والcalculations مرة كمان. طبعا ده توبك كبير بس إن شاء الله هنشرحه مع بعض برضو في الفيديوهات. هيكون في عندنا ionic bonding, covalent bonding, metallic bonding والelectrolysis. الانورجانيك بارت هيكون في جروب 1 alkali matter of periodic table، وجروب 7 halogens gases in the atmosphere and chemical test. والفيزيكال كيمستري هيكون عندنا rate of reaction و reversible reactions and equilibrium. بالنسبة للأورجانيك كيمستري بارت 2 في يونت 2 هيكون عندنا alcohols, carboxylic acids, esters و synthetic polymers. لو عندك أي سؤال يخص النظام بتاع المودولر related للكيمستري ممكن تبعتهولي في كومنت وإن شاء الله هرد عليك. إحنا هيكون لينا 2 فيديوز بالويك، هيكونوا الساعة 6 أو 6 PM Egypt time أو بتوقيت القاهرة. هيكونوا يومين في الأسبوع اللي هو هيكون Sunday و Wednesday. إن شاء الله هنشرح كل حاجة بالتفصيل، هحلك أسئلة كتير جدا، هنحل كتير قوي من الباست بيبرز. أنا مجمع لك الأسئلة بتاعت كل ريسون، يعني كل ريسون من دول من اللي أنت شايفه ده هيكون ليه الكويشنز اللي جت في الامتحان starting من 2019 لحد 2025 بكل ريسون. بمعنى إن مثلا let's say الانترودكشن بتاعت الأورجانيك ليها باست بيبر لوحدها أو ليها كلاسيفايد لوحدها، الكرود اويل ليه كلاسيفايد لوحده، الانرجيتكس لوحدها، حتى ايفن التوبكس الصغيره زي مثلا الكوفيرنت بوندنج، الايونيك بوندنج، كل واحد منهم ليه باست بيبر او ليه كلاسيفايد كويشنز لوحده. انا مجمعهم لك وهتشوفهم معايا برضو من خلال الفيديوهات، وبعد كل توبك ان شاء الله هنحل الاسئله بتاعته عشان بالنسبه لك التوبك ده يكون تمام وتقدر ان انت في الامتحان تجيب الفور مارك، وطبعا الاجابات هتكون according to المارك سكيم. يلا بينا خلينا نبدأ lesson 1. We'll start to talk now about principles of chemistry, section 1 part E, which is state of matter. As an introduction, everything around us is made of particles that we cannot see because they are so small. This chapter looks at the arrangement of particles in solids, liquids, and gases, and the ways in which these particles are arranged or can move around. As you can see, everything you look at it is solid or even liquid or gas. Gas, solid, liquid, metals, concrete, water, air, clouds, everything considered as solid or liquid or gas. So our learning objectives, what we want to cover in this lesson, you have to understand the 3 states of matter in terms of arrangement, movement, and the energy of particles. Also understand the interconversions between the three states of matter in terms of name of the interconversion, how they are achieved, and the change in arrangement, movement, and the energy of particles. Also understand how the results of experiments involving the dilution of colored solution and diffusion of gases can be explained. Also, in the second video, we'll discuss what is meant by solvent, solute, solution, and saturated solution. This part will be covered in the next video. Know what is meant by the term solubility in the unit of gram per 100 gram of solvent. This is considered as very important part, and also understand how to plot and interpret solubility curves. Also, we'll discuss one practical experiment to investigate the solubility of solid in water at a specific temperature, and this part, as I told you, which about solubility, is repeated in several exams, so I made it in a separate video. Let's start our topic or our lesson. I'm sure you know that matter is anything that has mass and takes up space. So matter can be classified by its physical state into solid, liquid, or gas, and this part will be explained in this topic, or can be classified by its chemical constitution into elements, compounds, or mixture, and this part will be the next topic. What are the main differences between solid, liquid, and gas? We are talking about solid, liquid, and gas arrangement. In case of solid, particles are close together in regular arrangement, as you can see, close together, touching each other with regular arrangement. In case of liquid, particles are close together but irregular arrangement. In case of gas, particles are far apart and also irregular. When we talk about motion, you have to describe motion as you can see it right now. To describe the motion in solid, you have to say vibrate about fixed position. It's not moving, it's just vibrating at fixed positions. While in case of liquid, they slide past each other slowly. You have to mention slide past each other. If in exam he told you particles slide past each other, you know he's talking about liquid. In case of gas, particles have random motion and move rapidly, not slowly like liquids. When we talk about shape, solids have fixed shape, liquids take the shape of container, also gases no fixed shape and take the shape of container. When we talk about volume, solid and liquids have fixed volume, while in case of gas, no fixed volume, it expands to fill its container. As you can see, arrangement of solid, liquid, and gas. Also, intermolecular forces of attraction, very strong in case of solid, moderate or even weak in case of liquid. We can say moderate, but it's very weak in case of gas. Compressibility. What is meant by compressibility? Ability to be compressed. You cannot compress solid. If you try to compress solid, cannot. It's difficult to compress liquid, but it's easy to compress gas. When we talk about diffusion, difficult in case of solid, almost no diffusion, slowly diffusion in case of liquid, and rapidly diffuse in case of gas. The part about kinetic particle theory is not required in your exam, not in your syllabus, but I add it in my notes to help you know some details I want you to know. When we talk about kinetic particle theory, it's used to explain physical properties of matter in terms of movement of its particles. All matter is made up of very small, tiny particles, which is atoms or molecules or even ions in constant motion. So, any matter made up of very tiny particles, whatever atoms. In case of noble gases, for example, consist of atoms. We can describe it as atoms. All matter consists of atoms, but we can describe the tiny particles as molecules in case of hydrogen, in case of oxygen molecules in case of water molecules, ions in case of sodium chloride, sodium ions and chloride ions, and so on. All these matter particles are in constant motion. The particles in these three states are arranged differently. We know arrangement, we just talk about arrangement, and they have different types of movement. Also, we describe movement and different energies. We'll talk about energies later in this topic. Matter changes its state quite easily, and the particles in a solid have less kinetic energy or movement than the particles of a liquid, which have less kinetic energy than the particles in a gas. Let's take some important notes. Gases can be compressed to form liquids by using high pressure and cooling. So if you cool gas, you'll convert it into liquid. And if you cool liquid to freezing, you can convert it into solid. To change solid into liquids, then into gas, heat energy must be used to provide particles with enough energy to overcome forces holding them together. So we can convert from solid to liquid by heating, and from liquid to gas also by heating, to provide enough energy to overcome forces of attraction holding them together. To change gases into liquids and then into solids involve cooling, as we just mentioned, to make particles move closer together. The temperature at which one state changes to another have specific names. It's like boiling point from liquid to gas, melting point, the point at which solid converted completely into liquid, freezing point, change from liquid to solid. So we'll talk now about interconversions of states of matter. As you can see, from liquid to gas, evaporation, or even boiling, from gas to liquid, condensation, from liquid to solid, freezing, and also by cooling. The blue arrow indicate cooling and the red arrow indicate heating. From solid to liquid, melting. We'll explain all of this in details in this topic. From solid to gas directly without passing the liquid phase is sublimation, and from gas to solid directly is called deposition. So let's start talking about melting point, MB. Melting point is considered as the temperature at which a pure solid substance, take care of this part, pure solid substance turns to a liquid. If a solid is heated, its particles gain energy, vibrate more, and the solid expand. So if we heat this solid, energy brought in heat, it will convert to liquid by melting at the melting point. So at the beginning, we just heat. Particles gain energy, move faster, vibrate more, solid expand. At the melting point, particles vibrate so much that they can slide over each other, converted into liquid, become liquid. Movement change from only vibration about fixed place to slide over each other by heating, by the energy that we provided. So from solid to liquid, melting. When liquid is cooled, energy taken out, it gives out energy and converted by freezing into solid. So we can say that freezing point is the reverse of melting and occur if the liquid is cooled down. You know, what is the freezing point of water? 0 degrees Celsius. But what is the melting point of ice? Also 0, same temperature. So the melting and the freezing points of any given substance are both the same temperature. Look at this part. Ice solid melt at 0, converted into liquid water. On heating, particles gain energy. As it warms up, some evaporates. Water evaporates at any temperature between 0 and 100, and the rest boils at 100 degrees Celsius to give steam or gas. Steam cooled. On cooling, particles lose energy and move more slowly. As they get closer together, the forces of attraction take over, they attract each other more. As you cool below 100, the water vapors begin to condense or liquefy until forming water, then water solidify or freezes at 0 to give ice. If a liquid is left with its surface exposed to air, it evaporates. If you left liquid like this, its surface exposed to air, it evaporates. Faster moving particles escaping from the surface to form gas. This means evaporate. So if a liquid is left with its surface exposed to air, just leaving a cup of water in the sun for 2 days and you found it empty. Why? Water evaporates, not boiled, because boiling occurs at 100 degrees Celsius and the temperature, the room temperature, or even the temperature in the sun, it's not reached to 100, so it evaporates, not boiled. If a liquid is left with its surface exposed to air, it evaporates. Evaporation takes place from the surface of the liquid. The larger the surface area, the faster the liquids evaporate. Look at this. Larger surface area, like as we draw, for example, this part. We'll draw it now. This considered as large surface area, and this one is considered as a small surface area. The larger the surface area, the faster the liquid evaporates. If the surface area is large, more particles can escape. Also, evaporation occurs at any point while boiling occurs at certain temperature. Boiling point, the temperature at which the liquid converted into vapor or gas. When liquid is heated, its particles gain energy. Liquid, energy brought in by heating. Boiling occurs, and also evaporation occurs before boiling and converted into gas. So when liquid is heated, particles gain energy, move faster, so the liquid expands. And at the boiling point, all particles gain enough energy to overcome forces, holding them together and break away to form gas. When gas is when gas is cooled, energy taken out, so condensing takes place. Condensation is considered as reverse of evaporation and occurs by cooling. If a gas is cooled, its particles lose energy, slow down their movement, so attraction between them holds them as a liquid. Remember that sublimation is conversion from solid to gas directly without passing liquid phase, and deposition, conversion of gas to solid directly. As you can see, solid energy brought in converted into gas directly with sublimation, and the gas cooled energy taken in and converted into solid. Working out the physical state of a substance at a particular temperature, important question in exam. A substance is a solid at a temperature below its melting point. Between its melting point and the boiling point, it's considered as a liquid, and above its boiling point, it's converted into gas. In science, we can decide whether the substance is a solid, a liquid, or a gas at room temperature by just looking at where it's melting and the boiling points in relation to room temperature. Look at this example. When we talk about oxygen, its melting point and the boiling point below room temperature. Room temperature is about 20-25. So melting point and the boiling point of oxygen, both of them below room temperature. So oxygen is considered as gas at room temperature. Let's talk about bromine. Bromine melting point less than 0, about -7, something like this. And its boiling point about 58, 59, and so on. So 25 is in between melting and the boiling point, so we are talking about liquid. Bromine is considered as a liquid. For lithium, its melting point is 180, about 180. So its melting point more than room temperature. This means lithium is a solid at room temperature. So we just mentioned that solid its melting point more than room temperature. A substance is a solid below its melting point. So at temperature 25, it's below its melting point. Between its melting point and the boiling point, so it's liquid. Or above its boiling point, it's a gas. Above boiling point is a gas. Take care of this part. This one is considered as dry ice. Dry ice subliming, converted directly from solid to gas. Notice white solid carbon dioxide in the beaker, white solid right here. The white cloud is because carbon dioxide gas produced is so cold that cause water vapor in the air converted from gas to liquid. Carbon dioxide gas itself invisible. We cannot see it. So, as we just mentioned, oxygen is a gas, bromine is a liquid, lithium is a solid at room temperature. How to test purity? A pure substance has a definite, sharp melting and boiling point. These are different from each substance. So we can measure boiling and melting temperature, and if it's sharp, this means the substance is pure. When a substance contains an impurity, its melting point force decrease. Like, for example, when we add salt to ice, its melting point or freezing point become -2, for example, and boiling point rises to 102 if we add salt to water. Or it may melt or boil over a range of temperature, not sharply. And also, take care of this part, the more impurities it has, the bigger the change in melting and boiling point, or the wider the temperature range over which melting and boiling occurs. If he told you that substances start to melt at 79 and completely melt at 81, and another substance start to melt at 75 and completely melted at 85, which one is more pure? For sure this one, because the range is only 2, and for this one the range is 10 degrees Celsius. The wider the temperature range, this means more impurities. So this one is considered as more pure. And the other one with the higher range is considered as containing more impurities. Let's talk about the last part in our video, which is atoms and diffusion. Atoms are all substances are made up of small particles called atoms. Elements, compounds, and mixtures all are made up of atoms or even molecules. When we talk about diffusion means spreading out and mixing process. Considered as random movement of molecules or even particles from region of high concentration to region of low concentration. Random movement of particles from region of high concentration to region of low concentration. Diffusion does not take place in solids. Also, diffusion in liquids is much slower than in gases. If you try to run inside the sea or even inside the pool, you will run slower than outside. This means diffusion inside the liquid, movement inside the liquid, slower than movement in the air. When we talk about examples of diffusion, look at this example. Potassium manganate 7 is considered as a purple crystal, as you can see, which diffuse in water. But after dissolving, it must dissolve at the beginning. We just mentioned that diffusion does not take place in solid. So solid crystals must dissolve first, then start to move with the liquid and spreading by random movement from high concentration around the crystal to lower concentration in the terminal. The spreading of solid throughout the liquid is considered as example of diffusion. Solid just dissolving, then start to spreading. The particles in a liquid move very slowly or even more slowly than particles in gas, as we just mentioned. Also, look at the other example, which is bromine. Bromine is red-brown liquid, which is volatile, easily turn into gas without heating. So as you can see right here, liquid bromine, it evaporates, or even it's volatile, turn into gas without heating, and its fume diffuse to fill the gas jar. First one, with red, or even separate the two jars. Once we remove the red, particles spread to fill the jar, but with random movement, not moving up only, just random movement. Look at this example. In this one, air, which is mostly nitrogen and oxygen, and the other jar with hydrogen gas. So we have two gas jars separated by red. So the molecules of gas in each jar are moving rapidly and randomly colliding with each other and the sides of the jar. Once the two jars put together, red is removed, we remove the red, then particles spread randomly. Particles diffuse randomly. So gas is allowed to mix together for a few minutes, and after a few minutes, hydrogen present up and down. The rapid movement of molecules allows hydrogen to diffuse into the bottom jar, even though it's lighter than air. It moves down and up by random motion. So we try to test both jars with lighted sprint. It makes pop sound. Pop sound indicates the presence of hydrogen gas. We will discuss test for hydrogen later. Last example is movement or formation of white cloud of solid ammonium chloride NH4Cl close to HCl. Why? Because ammonia moves faster, because ammonia lighter in mass. So ammonia gas move more distance than HCl. HCl move smaller distance than NH3, because the MR of NH3 is 17, nitrogen equal 14 from periodic table, and hydrogen equal 1, while HCl is 36.5 because Cl 35.5 and 1H by 1. So we just add 1 plus 35.5 gives 36.5. So HCl move slower while NH3 move faster. So the white cloud or white smoke formed close to HCl. The white cloud of ammonium chloride NH4Cl formed close to HCl as ammonia diffuse faster because it is light in mass, as you can see. Now we finish this part. In the next video, we'll start to discuss the solubility of solids. اللي مطلوب منك إن شاء الله تدعي لي دعوة حلوة بظهر الغيب وتدعي بالرحمة والمغفرة لأمي المتوفاة. مطلوب منك تعمل سبسكرايب في الشانل وتشاركها مع أصحابك وزمايلك عشان كله يستفيد إن شاء الله. ولو احتجت أي حاجة تقدر إن أنت تتواصل معايا من خلال الأرقام اللي قدامك ديت. ولو عندك أي سؤال تقدر إن أنت تشاركه في كومنت، وأنا هنزلك إن شاء الله أسئلة كتير قوي، بس من خلال فيديوهات هنحل كل classified وكل topical questions related to each topic, each part of topic even. أشوفكم على خير. زي ما اتفقت معاكم، ميعادنا بالنسبة ل OL Edexcel هيكون Sunday و Wednesday 6 PM Egypt time. هيكون في كمان فيديوهات ل AS Edexcel، وهيكون في كمان ل OL Cambridge، هيكونوا في مواعيد مختلفة، بس برضه هيكونوا الساعة 6 بس في أيام مختلفة. أشوفكم على خير إن شاء الله. السلام عليكم.